All right, guys, Mr. Damon here. I'm gonna try my first attempt at making a video for you guys. Hopefully this helps, and please send me any messages if you have any questions as we go through. All right, so this is the applications of the logarithmic and exponential function topic that we have been working at so far. I'm gonna give you guys a few types of questions here, and then the rest of the booklet you can try on your own. So the first one that we're gonna try here is the mice question, example 1. I'm stealing Navin's booklet here, so Navin, if I make any mistakes, it's actually your fault. There are 500 mice found in a field on June 1st. On June 20th, 800 mice are counted, so there's an increase of mice, and we're trying to figure out what the rate of these mice are, so then we can figure out how many mice there will be on June 28th. The nice thing about these questions is on the provincial exam or any sort of testing, they're always going to give you the formula. As you see here, A is equal to P E to the RT, and they'll always explain what you have, P, A, T, and R in full detail. So you don't have to figure out what that is, and you don't have to memorize any of these formulas in any way, shape, or form. There's a bit of a note here that says if R is greater than 0, then we have a function that increases exponentially. If R is less than 0, then it's gonna decrease. And we're gonna see what we end up with as we go through. So basically, like in grade 9, we're gonna substitute in exactly what we got. So P being the initial value, we have 500 mice originally, so that is our P value. Our final value we don't know for June 28th, but we do have a final value on June 20th, and that could help us get the rate at how much the rate is increasing or decreasing for these mice. So the final value we can start with is 800, and that'll help us get to the final answer. The time in days from June 1st to June 20th is 19 days, boys, not 20. And the rate of increase or decrease, we don't know. We're gonna try to figure that out. All right, so let's plug in and figure out what we got so far. So we got 800 is equal to 500. Remember, E is the letter or the number that we dealt with last class, natural number, or E being Euler's number using the natural log. R we don't know, and 19 is the days. Now that we're at this point, you'll notice that R is the only thing that we have to solve for, remembering that E is just some number. So since that is the only variable we have to solve for, we're gonna have to use logs in some way, shape, or form. Since we already have a number here and a number there, we might as well get this to be a little bit simpler. So a good strategy is to make that number smaller. Two ways to do that. If that works out nicely on the calculator as a decimal, go ahead. But you guys may notice that once that cancels, you got 2 zeros here on top and bottom. They cancel. You're ending up with 8/5 on the left. Just makes our numbers smaller and easier to deal with. And then we got E to the 19R on the right. I just switched around the R and the 19. Now that we have R in the unknown spot, but we got nothing else to add or subtract or divide, nothing like that, we might as well bring R down. You have two ways to bring R down, right? You've got the log on both sides, but from last time we also have ln on both sides. It's gonna make more sense to do ln right now because now you can do it with the letter E. We'll explain why in a second if you're not sure. If we ln on both sides, we get ln of 8/5 equals 19R times ln E. ln E is 1, and that was what we knew from last class, that it is equal to 1. ln of 8/5 equals 19R. Don't worry about that on the left, that's just gonna be some number, and we can use our calculator for every single one of these questions. Divide by 19, divide by 19. Plug this into a calculator. Just watch your brackets as you go through. So I've got ln of 8/5. I'm gonna close off that bracket, divide it by 19, and I end up with 0.0247 ... And you'll notice that that's the rate by which the mice are changing, which in this case would be a decrease. They are decreasing exponentially, which is a good sign if you're dealing with mice. But we need to figure out how many there are on June 28th, okay? Well, now we've got the rate for every single situation. We still have the initial value at 500. The rate now is 0.00247. Remember that on your calculator, that should be your ANS button as you go through. Time now is gonna be 27 days, and now we're trying to figure out the final amount. So this is basically a two-step question. A is equal to, in this case, 500. e to the 19 times 0.0247 dot dot dot. Again, that is where your calculator will come into play. Throw that calculator in there. I'm gonna go 500 times E. Remember, E is found with the LN button, usually in the second or shift button, however you wanna do that. And then 19 times, and now I'm gonna use my A and S button. And my final answer, in this case, if I would have actually used the correct time, being 27. Good catch there, AJ, I appreciate your help on that. Try that again, 27 times 0.0247 dot dot dot. You got your A and S button that you guys should be using. And in this case, you end up with 975.068. If we round that, that is 975. So again, I used the wrong date. That was 19 from the last one. I should have been using the 27 like I wrote above if I actually was paying attention. There are 975 mice found on June 28th. Okay, so that one is your two-type question, or two-step problem. Okay, find the rate, plug it in, solve it from there. The last type of example that we're going to do is this one here, example 4. All right, and in the notes, by the way, it does say example 1, but just match it. It looks exactly the same. Okay, for you guys, it's example 4. The pH scale is used to measure the acidity or the alkalinity of a solution. Okay, so chemistry guys, you probably recognize those terms. It's defined as pH is equal to negative log H plus, and H plus is the concentration of hydrogen ions. A lake affected by acid rain has a pH of 4.4, while a person suffering from heartburn has an acid pH of 1.2. How many times greater is the hydrogen ion concentration of the stomach than the lake, which seems kind of bizarre that our stomach has more acid than acid rain, but there you go. Okay, you're gonna separate these by them, kind of like by their own questions, because you want to figure out how many times greater one is than the other. So I'm gonna go acid rain, and that's gonna be 4.4, okay, from the pH formula. Okay, I'm rewriting this out, but you guys have it literally in the question. pH is 4.4 equal to negative log, and H plus is on its own. Divide by negative 1 on both sides because you have something attached to there. So we got negative 4.4 is equal to log H plus. Now the question is, how do I actually figure out what the concentration of hydrogen is? How do I get this by itself? Well, unlike the last few questions where we're plugging in and applying logs, logs are already here. So how do you go backwards? This is, if you want to write it down for yourself, kind of a backwards / go to exponential function question. Okay, we want to get H plus by itself. So what we're going to do is we're going to take the base of the log. It's invisible 10. Hope you know that by now. And that's going to be 10 to the negative 4.4. And that gets rid of the log. Okay, so we just applied the exponential part of that. Now the nice thing is when we do the stomach part of the question, it's gonna be exactly the same. All right, so we got 1.2 is equal to negative log H plus. If you wanna jump right to the negative 1, go ahead. Okay, so negative 1.2 is equal to log H plus. That's 10 to the negative 1.2 is equal to H plus. If I'm trying to figure out how many times greater something is than something else, right? Stomach acid greater than lake, then I am going to compare them by going stomach divided by rain, because stomach is going to be bigger than rain. If you notice in this case, if you know your negative exponents well enough, right, that means that this negative exponent is smaller than, well, technically bigger than this one, right? Negative 1.2 is bigger than negative 4.4, so that's why this is bigger than that one. We got 10 to the negative 1.2 divided by 10 negative 4.4. Believe it or not, and let's just double check on the calculator here. I've got an answer over there, but I'm just going to show you guys. I've got negative 1.2 there divided by 10 to the negative 4.4. Exciting stuff, seeing me work on the calculator. If I round that to a whole number, it is 1,585 times greater or more acidic in the stomach than acid rain. That's disgusting. All right, the rest of the booklet, you'll notice question 5, question 6, and question 7 have some pretty similar examples there. Just use the formula they give you and plug in, and whether it's times greater or just comparing the numbers in some way, they'll be very similar. All the notes you can find on the Google Classroom and on the Google Drive. Good luck, boys.